Hello everyone. So thank you for watching this video. So this is Math 2526 class C2. Okay. So we will continue for last class topic. So last class two sample problem. Right? Okay. So two sample problem is just that we say just a comparison. So the data we have like a data from sample 1, data from sample 2. So from those data, we have this like x bar follow normal, y bar follow normal, then x bar minus y bar follow this normal. Then we have this like this follow standard normal, right? Okay, so okay. So here for two sample problem, it's just a comparison. So here HO is no difference. So mu1 equal mu2. Mu1 equal mu2. Okay. So on the HO, we find mu1 minus mu2 equals 0, right? So we have this one follow normal. Okay. So x bar minus y bar, so sigma 1 square over n1, sigma 2 square over n2. This follows standard normal. But the question we say, we don't know sigma 1, sigma 2. So we replace sigma 1, sigma 2 by s1, s2. So we have this test statistic is this. X bar minus y bar. So this is our test statistic. So we can easily to calculate this number. So the question is, we want to determine this cutoff point, this test statistic. This number is a big number or small number. So we say for this problem, so we need to know the distribution for those things. Like which table we should check. Right? So in order to answer this question, we need to know which distribution for those things. So we can say this one will close to a t-distribution with degree of freedom. So degree of freedom, so we just pick a smaller one. Right? We have 2 degree of freedom. n1 minus 1, n2 minus 1, right? So we just pick a smaller one. Okay. Okay. So we say this is just loosely. We make those like loosely we can make this decision, but not so precisely, because so here we just say loosely. Okay. So now today let's consider special case. So a special case. Okay. So if we say if this sigma 1, sigma 2 same. So if if sigma 1 equals sigma 2 equals sigma, then we have this one. We can take this sigma 1. From here we can take sigma 1 square, sigma 2 square outside, become sigma, right? So we know this follow standard normal. Okay. So here just before we have sigma 1, sigma 2, we have 2 sigma. So by now we have only 1 sigma, right? From here from 2 sigma. From 2 sigma we just consider just from 2 sigma reduced to 1 sigma. Okay. So if we have only 1 sigma, then by the sigma by s, then we have exactly t distribution, right? Yeah. So we say replace replace 1 sigma, replace 1 sigma. Let's see here, 1 sigma to by S. If we just replace 1 sigma by S, then the distribution will become from Z to T. So this is actually T come from. So if we replace 2 sigma by S1 is 2, then this Z follow. Let's see, I put it here. Okay, we have some trouble, right? So replace 2 sigmas. 2 sigma by, let's say, like 2S, like S1, S2. Then we say this Z will not become T. Okay, so this is the basic idea. Like if we have only 1 sigma, then those things will become T. Okay, so here the question is how to replace this sigma by S. So here we have 2 S's, S1, S2. So replace by which one? Okay, so we defined those things. We introduced those things: pooled values and pooled standard deviation. So what is pooled variance? So we define pooled variance as weighted average of 2 values. We have S1 square, S2 square, right? We have 2 values. So we want to find a weighted average for them. So weighted on what? On their degree of freedom. So we for average, so let's check the many average should be weighted average. Like before we say average for 10 and 20, average just 20, 10 plus 20, like 10 plus 20 over 2, right? So this is average. But this average, we can put this as 1 over 2 times 10 plus 1 over 2 times 20, right? So we can say this average, we weight 10 and 20 the same. Okay, so now if the average weighted on 2 and 3, so this just become like so for 10, for this 10, so weighted as 2, right? So for 30, weighted as 3, so totally weight is 2 plus 3 is 5. So if weighted average of 10 and 20 weighted on these 2 numbers, then x bar becomes this, right? 2 times 10 over 5, or 2 over 5 times 10 plus 3 over 5 times 30. I'm sorry, I made a mistake here, 20. Okay. So based on this, we can say the pooled variance is just this. It's 1 square, it's 2 square. So weighted on their degree of freedom. So degree of freedom n minus 1. So here's n1 minus 1, so n2 minus 1, right? So totally is this, right? Total weight is this. Okay, n1 minus 1 plus n2 minus 1, n1 minus 1, n2 minus 1. Okay, so this is a weighted average. So you understand this, right? We just the pooled variance is the average, weighted average for S1 square, S2 square, weighted on those 2 numbers, degree of freedom. Okay. Okay, so weighted average actually is very common. So a simple example like this, like in class 1, the average is 84. Okay, 84. And in class 2, average is 81. Then so this 84, 81 is average for each class. So how about we want to find average exam score for all students? For there's two classes, put the two classes together. What is the average for all? So this average we cannot just like that. 84 plus 81 divided by 2. So this is totally long, right? So the average for all, we should check the average all is this, like total points divided by total people. So total number of people, class 1 we have 25, and class 2 we have 20, so we have 45, right? So 45. So if we just put the two classes together, we have 45 students, right? So for these 45 students, the total points equal, so class 1 average is 84. So total points for class 1 is 25 times 84, right? And the same like, so for class 2, total points is this. Okay, so this number, we also can say this equal 84 times this, 25 over 25 plus 20. And 81 times this, right? So we can regard this is the average of 84 and 81. So this is weighted average. Weighted average of 84. So weighted on what? Weighted on number of students, weighted on the 25 and 20, right? Weighted on the number of students, right? Okay. Okay, so now we understand what is the poured variance. So poured means put them together, right? Poured variance is this. Weighted average for S1 square variance weighted on the degree of freedom. Okay. Okay. So now we just replace this sigma by S. Okay. I'm sorry. This make me. This is a test statistic. So this is not follow standard normal. Follow T. I made a mistake. Follow T. Okay, so replace 1 sigma by S. Then we say normal, standard normal become T, right? So this T degree of freedom is this. So degree of freedom. So for add them up in 1 minus 1. In 2 minus 1, the sum of degree of freedoms. Okay, so now let's consider this problem again. Like we wanted to compare the two classes. Or can we say class 1 performs significantly better than class 2? Like same question, right? So we have some evidence. Class 1 average 84, class 2 average 81. So whether this difference is significant. So here, we want to change the problem. Let me say, we want to answer this question under the assumption of equal variance. We assume sigma 1, sigma 2 same. So we find like here we also can just this is standard deviation 5, or this is 6, or this standard deviation not quite close, so we can believe they're equal. Okay. Okay. So if we conduct this testing under this assumption, then test statistic, we should use different formula. A test statistic. So at first we need to find this port variance. Okay, so the port variance, this formula maybe you can forget. Okay, we can, so the formula looks quite complicated, we can forget it, but we need to understand this. Like this equal, so variance 5 square and 6 square, right? Variance 5 square, 6 square. So we just need to find the weighted average for them. So weighted average 5 square, 6 square. This is their variance. So weighted on what? Weighted on their degree of freedom. Okay. So this degree of freedom 24. This degree of freedom is 19, right? So totally, so here denominator 24 plus 19, right? So which is 43. Okay. So this is port variance. Okay. So you understand this, right? Yeah, the formula also so complicated. Looks like so complicated. So we just understand the weighted average for those variance 5 square, 6 square, so weighted on 24, 19, right? Okay, so we find this equals this number. Then is p take square root. Then this test statistic, this one. Okay, so let's check a test statistic. Okay, so equals this 84 minus 81. Then SP is 5.46. And so here 1 over 25, 1 over 20. So here we need a little bit of calculation, find the cut point. Let's see. Okay, so let's do a little bit of calculation. Okay. Let's see. My calculator not so good. 1 over 25. Okay, so let's see. Okay, so just like 10 divided by okay, so I found this number is 1.38 1.83. Okay, so now we want to determine that this number is big number or small number. 1.83. So this 1.83 is big number or small number. So then we need to check t distribution. So there's a t distribution. So degree of freedom. So degree of freedom is 43. Okay. So let's see. So let's check a t table. Find this. So okay. So we just need to find this t critical value. Then use this this critical value determine 1.83 is big number, small number. Okay, so let's check. Do I have the table? Oh, I do not have the table. Okay, but anyways, I use. So let's check this critical value. So from T table, so if we cannot find this degree of freedom 43, so from the table we just use close one, right? Degree of freedom as 40. Okay. So now let's see this. So alpha, what is alpha? Alpha is 5, 005, right? Okay, so let's check this table. Okay, so this alpha is 005. So 40, we just check 40. Okay, 40. 1.68. Okay, so we find that T star equal 1.68. Okay, so degree of freedom 40, so 1 till 005. We can find this T star is 1.68. Okay, so we can say use this as a standard, so we can say 1.83 is a big number, right? Big number. Okay, so like let's say we use this like, okay, here's 0, okay, here's 1.68, so use this 1.68 to make a judgment. So those number, small number, right? Small, those number, big number. So we can say 1.83 is a big number. So then what is your decision? So we can say, oh, the difference is significant, difference is big, or this number is big, then go back to here, we can say this difference, 3 points difference, is significant. So here, so if the data like this, then we can say class 1 performs significantly better than class 2. So here we use this assumption, right? Sigma 1 and sigma 2 same, variance equal. Okay. So if variance equal, then we say so theoretical difficult or gone, right? So we say this just follows t distribution, right? Exactly t distribution. Okay, and we know the degree of freedoms n1 minus 1 plus n2 minus 1. Okay. Okay, so now let's consider there's a problem. So we just check there's a problem again. So here we want to compare. We want to say whether this company A's certification level is better than company B's certification. We just say like here we have evidence. Company A is 3.51, so we know those numbers just come from this, like this certification level. So for customer, they pick one like from 1 to 5. So this number high means more satisfied. Okay. Okay. So we can find this A is quite small, so we can assume. So here under the assumption, the equivalence. We wanted to conduct the test to check whether we can say company A certification level is higher than that in company A or company 2. Okay, so here HO is mu1 equal mu2, so HA is mu1 larger than mu2. So here there is a test statistic, so Z value, T value. So we say this is a T value. Okay, because we know if we assume sigma 1 equals sigma 2, then this become exact T distribution or T value. Okay, so how to find SP square? How to find this Poor variance? The formula is like that. Okay, but here with the formulas looks complicated, but we understand this definition. So Poor variance is the weighted average for S1 weighted average for those S1 square is 2 square. Weighted average for those variance. So this we have this variance is 41 square, right? Or the other one is 42 square, right? So we want to find the average for them. But this average is a weighted average. Okay, so weighted on what? On their degree of freedom. So degree of freedom, we have 2 degree of freedom, 173 and 354, right? In -1, right? Yeah. Okay. So we find this equal. So this one degree of freedom 173, and this one is 354. So divided by total. Total is add them up, right? 354. So that's equals 725. So divided by 527, 527. Okay. So this is SP. So here after a little bit of calculation, we let's say find this. Let's see. Okay, so here I need some calculation. Let's see. Okay. Okay, so let's say this equal 173 multiply 51 square. Okay. Okay, so we found this equals 0.267. Okay, so then SP. So SP is just take a square root, right? So SP equal square root of this. So 517. Okay, so equal 0.517. Okay, so we can find the T value. So let's say, put it to here. Yeah, the T value is this. So this equals SP, so plug in here, SP equal 0.517. Okay, so now let's check this this number. So again, some calculation. So let's do this calculation. Okay. Okay. So after a little bit of calculation, we found this equal 5.64. Okay, so the degree of freedom is thus, right, 5.27. So this number is too big, yeah, 527. So we can use, we can check a T table or Z table, doesn't matter, right? So here, so if we, so we can make it, so we can say that this number is too big, okay? For no matter this is Z value or T value, so this number 5.64 are quite big, right? So we can say, say the decision is the difference is significant. Okay, the difference is significant. Okay, so here, so to this class is simple class. So this is, we just check a typical situation. We just check a typical situation when, so we assume sigma 1, sigma 2 the same. So if sigma 1, sigma 2 the same, then we just only need to replace one sigma by one s, right? So if we replace one sigma by one s, then we have exactly, we have T distribution, okay? So degree of freedom is n minus 1. The degree of freedom is add them up, like n1 minus 1 plus n2 minus 1. So the process, testing process is quite the same. Only thing, different things is the formula for find the test statistic is this one. X bar minus y bar SP take square root of 1 over n1 plus 1 over n2. So here we need to find SP. So we need to know how to find SP. So SP, we say we need to find variance first. Put the variance first. So there's a put the variance is just an average for these two variance. Right? It's 1 square into it's 2 squares. But this weighted average is weighted on degree of freedoms. Right? So n1 minus 1, weighted with n1 minus 1, n2 minus 1. Okay? So here we also introduce the important notation. So concept means weighted average. Okay? So weighted average. So please, so you should understand those things, the weighted average. Like for average, before we say average, just we just say average. Average is divided, add them up divided by n, right? So this average is just the weighted average one the same. So if weighted the average one was different, not the same, then we should do this way, right? So I hope like you can understand this simple example. weighted. We have two numbers, 10 but 20, but we want to find a weighted average. So weighted on those numbers. Okay, so just like that, 2, so here 3 is divided by total weights, right? Okay, so I hope you can understand this notation. Okay, so we start with the topic for two sample problem. Okay, two sample problem. So next class we will check many sample problems. Okay, so we can stop here. So see you next lecture.